In this lecture, guys, we're going to look at the basics of NumPy arrays. We're going to look at some of the NumPy array attributes and methods. So let's start with importing our NumPy as usual. We're going to do import NumPy as np, and then I'm going to define three NumPy arrays, one-dimensional, two-dimensional, three-dimensional. So let's do that. x1 equals np dot random rand. By the way, we looked at creating randomized array in the previous lecture. If you want to review that, go ahead and watch that video again. But in this video, I'm going to be defining three arrays here using the random module from NumPy. 10 size equals 6. This is one-dimensional array. By the way, the method we looked at in the previous lecture was something like this, but it's the same thing. It was random.randint 1 to 10, and if you want the size as 6, we can just define as that. Here we are explicitly defining it, like the size we need a 6-member or 6-element array. Here we didn't define that, so these are one and the same thing, and I'm going to show you that this is going to give you exactly the same result. Let's press enter and let's just review our x1. Let's now define our array using this guy. And let's look at x1. It should be a 6-member or 6-element array, and as you can see, it's a 6-element array. We have different values because we are using a random it's a random array, so every time you rerun it, it changes the values, it randomizes the values. So hopefully that makes sense. So again, I'm using, in the previous lecture I showed you a shortcut, but you can explicitly specify the size as 6. Okay, so this is our x1, right? I'm gonna remove all this here, so it's gonna be easier to work with, right? So let's remove that. Yeah, so now let's define x2 as well. So x2, I want x2 as a 2-dimensional array. So I'm just gonna copy this guy. 2-dimensional array. Size, I want 2-dimensional, so I'm gonna specify a tuple here. 3, 4, 3 rows and 4 columns. Likewise, I'm also gonna have a 3-dimensional array. Let's copy this. 3, 4, 5. As you can see, it has 3 dimensions, 3, 4, 5. It's gonna be a 3-dimensional array. And let's just run this now. And if you want to examine these, you can do that using this. This is x1, this is x2. As you can see, this is, there are 2 square brackets in the end. That means it's a 2-dimensional array. 3 brackets in the end. This is a 3-dimensional array, right? So now look at some of the NumPy's built-in attributes. Okay, the first thing that I'm going to show you guys is let's look at ndim, which is, this is how it's spelled, ndim. So this is an attribute, this is a built-in attribute of NumPy. So what we can do is we can actually do x3 dot ndim, and it's going to give you, by the way, there's no bracket or anything like that, it's just the name, and it's going to give you dimension. Okay, so as you can see, x3 is a 3-dimensional array, so we get 3. If we do x2 dot ndim, it should be 2, right? If we do x1 dot ndim, it's gonna be 1. So ndim gives you the dimension of the array. Likewise, we also have shape. So the shape will give you what kind of array is that. Is it a 1-dimensional array or is it a 2x2 array? So it just gives you the shape of that array. So if you do x1, just 1 row, there's no column because it's a 1-dimensional array. If you do x3, it should give you 3, 4, 5. So that means it's a 3-dimensional array. If you do x2, it should be 3, 4 row and column. So that's a two-dimensional array. Just like shape, we have one more thing here, which is the size. So if I do x1 dot size, by the way, these are all attributes. We don't use parentheses or these brackets when we are talking about attributes, because these are not methods or functions. So x1 dot size is going to give you 6. X2 dot size, 6 means it's a 6-element array. X2 dot size, it should be 3 times 4 is 12. That's why we're getting this 12 here. X3 dot size, let me give you an exercise. Pause this video for a moment and think what the size for the x3 array is going to be. By the way, x3 array is right here. Again, to get the size, what you do is you multiply the dimensions. Pause the video and tell me what the x3 dot size is going to be. I hope you got that. The x3 dot size is going to be 3 times 4 times 5, which is 60. So let's see. And there you have it. X3 dot size is 60, meaning x3 array is going to have 60 elements in it. Okay, so that's what the size is. So we looked at ndim, which gives us the dimension of that array, whether it's a 1-dimensional, 2-dimensional, 3-dimensional array. Shape gives us, is it a 3 by 4 array? Is it a 3 by 4 by 5 array? So it just gives us the shape. Size gives us how many elements do we have inside that array. So these are some of the attributes. I'm going to show you a couple more attributes. Let's look at x3 right here. Okay, so this is a 3-dimensional array, by the way. I'm going to cover multi-dimensional arrays in much more detail in a future lecture, but for now this is a 3-dimensional array because we have 3 square brackets here. If I ask you what's the maximum value in this array, so you're going to do x3 dot max. By the way, this is a method, that's why we are using these brackets or parentheses here, and this is going to give you 9. So 9 is the highest value or the maximum value in this 3-dimensional array. And you can see that, right? You can just eyeball it and you can see 9 is the highest value we have. Likewise, what's the minimum value? So for that, you're going to use the min method. It's a 0 here. Okay, this is the least or the minimum value of this array. If I ask your position of the maximum element, which is 9, what's the position of that guy in the 3-dimensional array? So to do that, what we do is called x3 dot argmax. It's going to give us the position of the maximum element in your array, which is 14. And you might be asking, how is that? Okay, so let's look at it. So the position for the maximum element, which is 9. So let's see where the 9 is. Okay, so 9, the first 9 is here. Okay, so let's see. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the maximum element, number 9 in the array, has a position of 14, which is this guy here, argmax. Likewise, we can get the position of the least or the minimum element from the array by using argmin. Again, the minimum element was, the smallest element in the array was 0. To get the position, we do argmin. Let's see, 20. So let's see, its first 0 is here. So we were at 14 here, 14, 15, 16, 17, 18, 19, and 20. So 20 is the position. 0 is at 20th position in the array, and that's what we have it here. So we looked at max, min, the position of max and position of min using argmax and argmin. And now I'm going to show you guys how can you reshape an array. Okay, this is the last method I'm going to show you in this lecture. Is the reshape, which is pretty interesting. Okay, and very important as well. So imagine you have a 1-dimensional array, which is this x1 here, and you want to reshape this guy into a 3 by 3 array. Okay, because we have 6 members here, 1, 2, 3, 4, 5, 6, right? We can shape this guy. Now thinking about, we cannot shape this guy into a 3 by 3. I'll tell you afterwards. But we can shape this into a 3 by 2 array. Okay. Let's do that. So to do that, we can do x1 dot reshape method. This is a method, that's why we're using these brackets here, and we can specify 2 by 3 or 3 by 2, one and the same thing, element wise. So here we have 3 rows, 1, 2 and 3, and 2 columns. Okay, 1 and 2. We can also reshape this one dimensional array into a 2 by 3. 2 by 3, meaning we will have 2 rows now and 3 columns. And there you have it, 2 rows and 3 columns, 1, 2, 3. But with same number of elements. Okay, we will have 6. 2 times 3 is 6. Again, 3 times 2 is 6. That's why you can reshape these rows and columns, but the elements are the same. Again, to reshape any one-dimensional array into a multi-dimensional array, make sure the sizing is actually equal. Meaning here we have 6 elements in this one-dimensional array. When I reshaped it into a two-dimensional array, the elements are still the same, right? 3 times 2 is 6. 2 times 3 is 6, which matches with the total number of elements in this one-dimensional array. You cannot you cannot do 3 comma 3, because 3 times 3 is 9, right? So let's show you. It's going to give you an error. There you have it. Cannot reshape array of size 6 into shape 3 comma 3, because shape 3 comma 3 means it needs 9 elements in that array, but we only have 6 here. Okay, so you cannot do that. Make sure the number of elements in this one-dimensional array matches the multiplication of whatever you're trying to do, the rows and column. Okay, again, it cannot be 3 comma 4, because again it's more than 6, right? Cannot be. That's why I did 3 comma 2, because 3 times 2 is 6, which matches with the elements here, number of elements there. So there you have it. We covered some nice attributes for NumPy, and also covered some very interesting and useful NumPy methods. Thank you so much guys for watching.